Hey everyone, Yanni, thank you very much for that introduction and for enjoying my talk and heaping lots of pressure on this one. Hooray, perfect. Sorry about that. Cool. Yeah, so my name's Jack, come from London. I work for a company called Thread, and I'm here today to talk about testing in JavaScript. When I first set out to create a talk, I actually wanted to do a talk exclusively about testing React. But when I started putting the content together, what I really realized is that actually there isn't that much to say about testing React specifically, and we will cover that. I'm aware this is a React conference, but actually most of my talk just boils down to how to write good tests. And I'm hopeful that this advice will be useful if you do want to go and test your React application. But if you're working maybe on the back end or in a different language to JavaScript sometimes, hopefully some of this advice will help you improve your tests for your application regardless of exactly what it is. There are a lot of very different opinions about testing. There's a lot of arguments on the internet about it. But what I really want to start with is saying that tests are only as useful as the effort that you put into them. I've seen people have really bad experiences with testing, and it comes really down to the fact they're not willing to put in the investment up front to make it work. So I want to talk today about the kind of things where you should kind of put your effort, where you should focus on to leave you with a test suite that doesn't become a real pain as your application grows. I think we'd all agree that it's important that your application code, on the whole, ideally, is well written, it's maintainable, and it's easy to work with. Of course, any big application will have points that you don't like working or little rough corners you try and hide away from the new hires. But on the whole, we try and strive for well-written apps. I think it's even more important to have well-written tests. The reason being that you don't write tests for your tests. So your application code, it might be a bit rough around the edges, but if it's covered with some tests, you can probably deal with that and put up with those rough edges. But you haven't got tests for your tests. And so if you have bad tests, it can be very hard to get back from that and refactor them away. So there's two solutions here. You could improve your tests and put effort into that, or you could write some tests for your tests. But if you write tests for your tests, you're going to need tests to test your tests. And so really, you end up in this black hole of testing tests, and that's not a place we want to be. So that's one solution. The other is to actually think about what makes a good test and go from there and work on keeping your tests really easy and fun to work with. So as I said, I work for a company called Thread. It looks like this. We sell clothes on the internet. And we are hiring as well if anyone fancies coming over to London for a bit. Apparently there's good meetups there and good talkers there, according to Yanni. And there's three parts to a really good unit test. It clearly says what's being tested. It has the string which describes what's going on. And then there are three clear parts inside it. There's the setup, the actual thing that you call, the invocation under the code that's being tested, and then asserting on the results, like what actually did we expect to happen. So for example, I've got an item finder here that searches through all the items we sell on Thread to find shirts with a particular price range. So we set up, we create our dummy items, then we invoke the code under test, the result equals item finder line, and then we expect that the result equals something. This is the bare bones of a unit test. If you take one thing away from this talk, it should be that if all of your tests look like this, you're going to be in a pretty good place. They all very clearly say, my setup, here's the thing I'm testing, and here's what I'm expecting to happen, then you're going to enjoy working with those tests. A good way to think about this is you should be able to look at a single it, and again, I'm using a library called Jest, which is an excellent JavaScript testing library. Your library might not call it it, they might use like test or describe or lots of other terms, adjust it for the framework you use, but you should be able to look at one of these tests and know everything that's going on. That makes it really easy for you as a developer to come in and see what's going on. And also understand immediately what the test is trying to prove. Tests should have no external dependencies. What I mean by external dependencies is that you should just be testing one thing. If you think about why a unit test is called a unit test, like where the name actually comes from, it's because we're testing a unit of code. We're testing one isolated little bit of our code base. If those tests have to test or set up lots of other things along the way to test this one unit, that's just going to make a very long, hard test to understand. Kind of better way to think about this maybe is if your test can fail, but any of the code in your test, let's try that sentence all over again. If your test can fail, but the code changes that isn't related to the test, your test isn't properly isolated. So some unrelated code over here breaks an unrelated test over here. That's going to be very frustrating. And we've seen this play out multiple times. This is a huge cause of confusion in large code bases. I changed user.js, but suddenly I'm getting a test failure in blogpost.js, whatever it may be. This is one of the things that really puts people off testing. They get this sense that tests are just brittle, and all they do is they just break weirdly out of the blue. And then you just have to fix them. But you can't really see the point of fixing them because you don't really know why it broke in the first place. So remembering that unit tests are called unit tests because they really have to zoom in on a particular piece, a particular unit of your code, is a really good way to think about that. Something that lets us kind of do that and achieve this is spies or mocks. But mocks doesn't really work with the James Bond thing that I'm going for, so I've gone with spies. You'll find terms like spies, mocks, doubles, stubs. There's probably at least 10 more I've forgotten. They've all got like subtly different meanings, but really they all mean much of the same thing. We've just come up with lots of different terms for them to keep it confusing. Mocking is faking a function's implementation for the purpose of a test. This is you saying, I know that my code has to call this function, but for what I'm testing right now, I actually don't need to care about it. I don't need to worry about it. So I want to take an example of the thread code base in a test, and I had two choices of how to write it, and I want to talk you through why I made the choice that I made. So in thread, we have a thing called thread events. And thread events is how we monitor what people do throughout the site. So we know which buttons you click, which items you add to your cart, which you then maybe remove from your cart, which items you check out with. And we use this a lot to analyze kind of product and see if we can improve certain aspects of our product. And so in the front-end code base, you can import a thread events logger. And you can call log, and you give it a name and some data. That kind of pings it off to our service, which kind of puts it all together, chucks it in a database, and we can analyze that later. So here I've got this function, process user click on item. And that's the function I want to test. This is my unit. But you'll see I've got an external dependency, the thread events logger. And so I explicitly don't want to test this. I'm not here to test that the thread events logger does its thing. I'm here to test that when I click on the item, the stuff that I expect happens. So how do we write this test? Because we do want to check that when I click on this thing, we store a thread event. That's like an important bit of behavior. If we suddenly stop storing events when we add items to cart, all our analysis is going to be thrown out of line. But how do I do that in this test? I've really got two options at this point. The first is that I call the function, and then I go into the big list of events that we generate, I find the last one, and I check that it has all the right data attached to it. But what you'll notice about option one is that it's not just testing my process click function, but it's actually also testing the thread events logger. It's checking that we gave data to the thread events logger, and it's made it into our event log. Option two instead mocks it. It replaces it with a fake function. And instead of saying, well, thread events logger was called, and here's what happens, we just assert that it was called, because that's enough here. We're not here to test the thread events logger really thoroughly. We're here to test our process user click function. It's important to note you can only do this if the thread events logger itself is thoroughly unit tested. That's the goal that we're heading for here. You have each unit of code with its own tests, and then if something happens to crop up, kind of unrelated, you can just mock it out for the purpose of a unit test. I'm focusing primarily on unit tests today, but it's also important to note that we would have kind of higher-level integration tests or end-to-end tests using something like Cypress that would check that all these things work together. One of the downsides of mocking and of unit testing is that you test each bit on its own, but you never have any tests that check it all comes together to produce your application. That's when you would need some integration or end-to-end tests. Really, you should be thinking about this as just don't test things twice. This is what leads to those random test breaks that I mentioned earlier, when like an unrelated test file changes because you touch something over here. It's normally because you've got tests in places you don't need them. Mocks are also really useful for avoiding like quite awkward browser things that we just are a pain to test. So we work in the browser most of the time, or a lot of the time we were doing things like redirecting the user or reading browser-specific bits of data. And it can be quite hard at times to kind of set up the browser to be in the state you need it to test something. A good example here is we've got a redirect user function, and it's using window.location.assign, where you give it a URL, and it will just redirect the user off to that URL. Now, how are we supposed to test this? We could test this by like, writing a test that fires up a browser, runs the function, and then checks what the URL is. That's just quite a lot of setup, it's quite a lot of faff, and it's going to be quite a brittle test, because anything that involves actually loading up a browser and sending it instructions is always going to be a bit flaky and a bit rough around the edges. So again, we can use mocks or spies, and again, in Jest, the syntax is jest.spyon. This will be similar depending on whichever framework you use. And we just mock the implementation to not do anything. And then I can check that it's been called with the right thing. So now I'm still testing what I need to test, that if I'm a logged in user, I get redirected away to /home. But we haven't had to like set up the browser or rely on the browser actually doing its thing. We're just checking that it's testing it. And this is fine because you should be able to assume that window.location.assign as a native function that is provided to you, you can assume that that works. It's not your job to retest all the browser implementation details. When you come into using mocks, you need to be really careful. There's a very common gotcha that you need to make sure you clear them out after every single test. This comes back to what I was talking about earlier, that tests should be isolated. This also means that one test, the code in there, shouldn't be able to influence the result of another. Again, depending on your framework, but in Jest, mocks won't automatically be cleared for you between tests. So you see the second test here says we expect window.location.assign not to have been called. This test will actually fail with the test code as it is, because the first test called it for us. And by default, mocks aren't being cleared between each test. Now, you can configure Jest in a number of ways to avoid this. You can put it in package.json, or you can use before each and just call a function called clear all mocks. But if you ever find you're getting weird results where a mock is being called, but you don't think it should be, or vice versa, there's a solid chance that you've probably forgotten to kind of wipe the slate clean between every single test. And mocks are really an essential tool. If you've not come across them before, or you find them a little odd to work with, I'd really recommend getting used to them and getting comfortable using them. You certainly can overuse them. You shouldn't just start mocking everything as your default approach, but it should be one of the tools you are ready to reach for when you think you need to isolate a test more effectively. We just saw before each there. Before each is a great way to run code before every single test. It will just run automatically for you, but it can make a test quite hard to work with, so you've got to be careful not to fall into traps. If you remember the three things that make a good test, the setup, the invocation, and the assertion, we look at this test, we're missing one particular bit. At this point, we're missing the setup. This items variable, no idea where it's come from. It's not, I can't see it in this test. Where is it coming from? If you scroll up to the top of that test file, you'll see it set in a before each. And this isn't what we want. A good test actually sets that data up for us right in line there and then. Now, you might be saying, but Jack, if you do this every time and you've got lots of tests in this file, you're going to end up with lots of these. You're just going to have the same setup over and over again. And we've been taught since the first day you start coding, do not repeat yourself. It's just a rule. It's a rule that we all follow at all times. And this isn't great, because let's say that you need to change the items once. You're going to have to change it in a bunch of different places. But there's nothing to stop you just using regular refactoring and code techniques within your test files. I think people seem a bit hesitant to do it. But if this was me and I have all this code like this, I would do whatever I would do if this was a React component or a regular JavaScript in the browser. I'll just create a function. I'll create a function called getItems, which returns me that list of items. And I'll use that everywhere I need those items. So we're still creating the data in each place. When you look at the individual you can see the getItems call. And it's then very easy as a developer to jump up to the definition and see the data. So don't be afraid to almost refactor your tests as if you would regular code. And consistent test data is really important too. It's important that your test data actually looks roughly like your real data, else you could get kind of confusing results if stuff doesn't align, or you'll get bugs in production that don't occur in your test because the data isn't accurate. You've probably, if you work on an application, you've probably got a couple of objects or names that kind of come up a lot. So we sell clothes at Thread, and we call them items. So if you go through the Thread code base, the test, you'll find the word item a lot. We have a lot of item objects that pop up. In every test, we have a const dummy item equals, and we create it. And then one day, let's say the items API changes. We now have a new property called button type. Suddenly, all our unit tests don't have this property, and they're now out of date. This probably isn't the end of the world, but it's good practice to try and keep these up to date and aligned as much as you can. We can solve this with what's called a factory. A factory is effectively a way for you to say, hey, I want an item for the purpose of a test. It's a shameless plug, but I wrote a library to make these easier. It's called testDatabot. But you can achieve this with just regular functions as well. What testDatabot does is it says, OK, you tell me what an item looks like. So here I say, well, the item has a brand, which is a random name. It uses the faker library. It has images, which is an array of image URLs, and there's 3 of them, and so on. And then whenever you want an item, you just ask the item builder or the item factory for one of those items. And now if the structure of an item changes, I just come and update this bit of code, and all my tests are updated for me. So having some form of that, whether it's this library, another library, just plain old functions, is really important. We've talked already about brittle tests. I just want to cover them in a bit more detail. This is a pretty common complaint. When I change the code, I have to change the tests as well. So the work I have to do has doubled. I've gone in, I've refactored some code, but that's broken the test for that code. If you find this happening often, if you're just refactoring and not changing the behavior, but your tests are breaking, that's a pretty good sign that the way you've written those tests isn't quite right. Objects have what's called a contract. This is the public API they provide. So if you write an API for something, you write a JavaScript object that exposes a few functions, that is the contract that this object is providing. And that's the contract you should stick to when you write the test. So I've got a shirt finder here, which finds me shirts with a maximum price of £50. And it has, I know because I wrote the shirt finder, I know it has an internal variable called found shirts with 2 underscores, which apparently makes it private, ish. I think it would be a hash these days, might actually make that really private. I don't know. And we could test on found shirts, or we could test on the get shirts function. The first one, underscore found shirts, that's an internal implementation detail. And so this is something that I might go into the shirt finder and refactor that away, and now my tests are breaking, even though nothing has changed functionally. If I use the bottom line, the get shirts function, I'm sticking to the public API, so I can refactor internal details and not have my test break. And this is exactly what you want. You should be able to rewrite code without changing all your tests. And you should test things just by calling them, just like you would in real life if you were using them. When you're writing a test, think like, is this how I would call this thing if I wasn't writing a test, if I was writing the actual application code? A common mistake that I've made many times that has caused me a lot of time lost and kind of banging my head against the wall, and it's going to sound weird, but stick with me, is when writing new tests, you need to make sure that they fail. So let's say you've got a bit of code that isn't tested, and you've decided you need to refactor it, but first you want to write some tests to help you with that. So I write a test for my item finder, and there's a problem with this test, but the problem isn't going to make the test fail. The problem, if you think back to those 3 things, is that there is no assertion. There is no actual expectation here. At no point am I saying I expect shirts to equal this. Not all frameworks, but some, including Jest, will actually treat this as a pass, because the way they work is that a fail is when a test kind of errors with an expectation error. And kind of no error means a pass. So the test here is passing. So if you are struggling with tests failing, just remove the assertions, and they'll go green straight away. And many test frameworks will let you do this. They'll let you pass a test without an assertion. Most will actually let you avoid that by explicitly saying, I'm expecting 2 assertions here, and they'll make sure that you actually make those. But it's a really good practice. If you're writing a test and it passes straight away, be a bit suspicious. Try and break it. Like, deliberately make the test wrong. Deliberately go to the original code and break it. Like, change a number 1 to a number 2. Make sure it breaks. Because else you'll find that you write tests that are passing, but only because they're not actually doing what you think. Testing is really good for getting small feedback loops. And this is something that you will kind of reach the next level, in my opinion, of productivity if you can achieve small feedback between writing your code and making sure that it's working. So as a developer, you probably do this every day. Write code, check it worked. Write code, check it worked. Write code, check it worked. Or if you're Yanni, you don't need to check it worked because you know it's going to work. But we're not all as lucky as him. And the key is that the time between writing the code and checking that it worked should be as short as possible. This is not allowed. This isn't good. We write the code, well, we've got to wait for Webpack to rebundle. Then we're going to manually refresh the browser. Oh, wait, Chrome crashed, so I better close that and reopen it again. And then I need to click the button that I'm working on, and I need to tab back to my editor. This is slow. This is far too slow, and it's just not productive. What you really should be aiming for is write code, hit save, tests are run for you automatically. Whether it's in a terminal, in the browser, however you prefer to do this, in whatever editor you use, it should be very quick from hitting save in your editor to your test running for you. You'll just find this really, really productive. It's a really nice way to fix bugs. Let's say we find a bug in a price filtering function we have on thread. What I do, if possible, rather than kind of get that bug in the browser and see it in the console of a browser, is I try and prove it in a failing test. So say I'm going to write my test, and we check that this test, in theory, should be passing, but we know the bug is going to make it fail. So we run it, and we get the bug. But now I've got that really quick feedback loop because I have a test that proves the bug, and I have a test now that I can check if I've fixed the bug or not. So we fix the bug without changing the test, crucially. You can now just focus on the implementation, rerun the test, and it passes. So not only have you got validation, you've fixed that bug, you've also now ensured that that bug can never come back ever again because there's a test explicitly saying that it can't. If you do this every time you get a bug, you're going to end up with a pretty robust application and also avoid regressions where old bugs accidentally get reintroduced. This short feedback loop also can lead to confident refactoring. Has anyone out of interest heard of the phrase red, green refactor? A couple of people, the cool people in the room, have heard of it. Excellent. So red, green refactor is a way of working where you write a test for some code that you're about to write, you haven't written yet. This is kind of an approach of test-driven development, or TDD. You write some code, you write the test, you see it fail. You then just have to get that test green, no matter how ugly the code you write. At this point, code quality doesn't matter. Write the test, make it green. Once it's green, you can then spend however long as you want or need refactoring it to be much nicer code that you're happier. But you can do this really confidently because you've got a test that proves that you haven't broken anything by doing your refactoring. So you write the test, you see it fail. You write the code to make it pass, not worrying about if this is your nicest code, like, or should I use a reduce or a map or a filter or whatever? Should I use let or const or var? It doesn't matter at this point, just make the test pass. And then with this test, you can rewrite the code using the test to guide you. This is a really productive way of working. If you couple it with that feedback loop where you've got maybe your terminal on one half of your screen and your code on the other, you hit save and it's just rerunning, you're going to find that really productive. And if you embrace tests, you should get to a point where you feel slightly uncomfortable with a failing test. You should be uncomfortable doing like refactoring or extra work when you have a test red. It should be all about getting that test green. So that's kind of some of my experiences just generally testing that I think is applicable to JavaScript. I used to be a Ruby developer, so it's applicable to Ruby too, and effectively any language or framework or application. I want to talk a little bit about testing React. And really, my main motivation here is because I did a video course on it that you should all buy. It's called Testing React with Enzyme and Jest. This is a very shameless plug. But luckily it was Black Friday last week. So you can use the code JackFriday. Yep, get it? Thank you. Someone laughed. Henky's the guy I work with. He's laughing. He's supporting me. You can use the code JackFriday to get 40% off. And look, they did, and they love it. It's great. Look at that. Panic. I should also say half the videos are free on YouTube, so feel free to go and check them out before deciding to give me your hard-earned money. There is only one rule for testing React components. One thing you need to know to ensure that you can test your React efficiently. And rather than tell you what that is straight away, I want to give you an example of a question to ask that is a bad question when it comes to testing React. So I've heard there's this thing called hooks coming. I don't know if you've heard of it or if it's been mentioned. But there's these hooks, I think, coming. Don't really know what they are, but they're coming to React 16.7 or whatever. And so you might be thinking, well, Jack, how do I test hooks in React? It's a pretty valid question, you might think. I'm here to give you the easiest answer, is that you don't. Just don't bother. And there's many reasons. One, because they're the best thing ever, and they're obviously never going to break, so you don't need to test them. But more realistically, if you think back to when I was talking about contracts earlier, React components have a contract. This is an excellent stock photo. If you think about what is a React components contract? Well, a React components contract is what it shows to the user, what it renders on the page, what it does when the user clicks the button, fills in the form, toggles, whatever. That is what the React component is offering. So that is what you should be testing. You shouldn't be testing the internal details of a React component. You should be testing your components as if you are the user. So you have a test, and you have a big black line between the test and your component. This is a button component, by the way. Right? All right, thank you. Good. I wasn't sure if you'd all got it, because I couldn't hear the laughter, so I just wanted to mention it. So this is a button component. But when you're testing it, you should be testing it as if there was a big wall, a big brick wall built between you and that component. And so you can't reach in and look at the value of a certain state that you set via a hook. You can't reach in and read the value of a prop or whatever it may be. You can't reach in and call some function in your React component. You should do everything as the user does it. So I do a lot of testing using a library called Enzyme. And it lets you do both of these approaches, the approach where you have the brick wall and the approach where you don't. So approach one is the bad approach. Here, I simulate a click event, but then I reach into the wrapper to pull its state out and check that it's disabled. The alternative is I create the button, I click it, and then I check its props to see if it's disabled. This is a much better test because the props here is effectively what's being shown to the user. This reaches into the component to read some state, the first one. That's something that you don't want to do. This is a good, you can think of this as really a way to lead to brittle tests. What if your colleague comes in and they think is disabled is a weird term, we'll just change it to be disabled. Then suddenly your tests are broken, even though your functionality of the React component is the same as it always was. But if you read the property on the button that's being output to the user, you'll see that test will still work fine, even if you rename the internal state details. Now, so I'm a big fan and have used Enzyme for many years. I'm sure there are some of you here who have used Kelsey Dodd's React testing library. I believe there are some others as well. It actually doesn't matter at this point which one you use if you keep the kind of brick wall in your head. If you think like that, you can use Enzyme perfectly well. The benefit of React testing library is that it actually deliberately, by design, doesn't let you do it the bad way. It only lets you do it the good way. So if you're not sure, that might be a better option. But I wouldn't immediately start ditching Enzyme. If you keep these rules in your head, you'll be able to write really good tests. So just to sum up, kind of final key takeaway points. Remember what makes a good test: setup, invocation, and then an assertion. If each of your unit tests has those 3 bits, you're going to be in a really good place. Avoid brittle tests. Test the public contract, not internal details. And when it comes to React, the framework is less important than testing like the user. Write your tests as if you were a user in the browser. Sometimes I've actually had the browser up and I've gone through the steps and then replicated that in code. If you enjoyed this talk or you enjoyed talking about testing generally, you might enjoy this YouTube video. I'll put the slides up on Speaker Deck in a bit. It was Kent and myself chatting for an hour on our approaches to testing React and generally testing and a whole bunch of stuff. So that might be of interest. And I'm around all day and in the party as well. Feel free to come up to me and just say hello and chat if you'd like to. If you can't find me, tweet me, and I'll answer you either over Twitter or come and find you too. And thank you very much for listening.